Welcome back to the introduction of RxJS. In this video we'll discuss operators, and the main reason RxJS is useful is mainly for the power of their operators. So even though the observable is the foundation, operators are essential for composing complex asynchronous code in a declarative manner. So if you haven't seen the previous videos on setting up the coding environment and the introduction to what observables are, I'd highly encourage you to check that out first. So let's get into operators. So there's two main types of operators, and they are the creation operators and the pipeable operators. So let's first talk about the creation operators. And a creation operator is essentially called to create a new observable. So if we go ahead and we import, and the most basic creation observable there is probably the of, and we've seen this in the previous videos. And the creation observables we can just import straight from RxJS, and we can see that if we create a constant observable and then we say of let's say the array 1, 2 and 3, recall that we create an observable and then we subscribe to that observable with an observer. So we can subscribe to it, and by default if we pass in just one function, the way we handle that is with the next observer function. So that will be the default. So what they will do is our observer is just going to take the data and it's going to console log it. So it's going to take the observable, it will subscribe to the observable, and then it will do something with that. So okay, let's go ahead and just open up, we'll do an npm start, and we can close that down. And if we go to localhost 8080, I think we configured it to, yep. And we open up the console, we can see that in the very simplest case we've been given an array of 1, 2, 3. If we refresh that, once again we get the array 1, 2, 3. So that's what of is doing for us. Likewise, there is a very similar one, a similar creation observable, and I might just write up here creation operator. So creation operator, and another type that we can import is the from creation operator. And if we just comment out that, it behaves in a very similar way. So if we subscribe to from, rather than seeing an array, we see each individual element being console logged out. So that's the key difference between the two creation observables, of and from, and they're probably the most basic way to convert data of most forms into an observable. So the next creation observable we'll take a look at is the interval. So let's go ahead and grab that, and we'll just comment this out. So what we'll do here is we'll call the interval creation operator, and we'll give it argument which is in milliseconds. And if we go ahead and we just save that, what we'll see is we get 0, 1, 2, 3, 4 and so on, and they'll just continue on forever. And essentially what the interval is doing is it creates an observable that emits a new ascending number each specified period of time. So we've specified 1 second here, so every second it will be displayed, and we're just subscribing to that with our observer, our next console log for each observable that's being emitted. So okay, so the next one we can take a look at is the from event. So there's from, and there's also from event, and for this we'll need a button. So I might go ahead and close that. In our HTML file, I'll just create a button, and I'll just say click me with an exclamation mark, and then we can just use a little bit of JavaScript here, and we can say let button equal document.querySelector, and we'll just get the element button. And what we can do with that DOM element is we can say, just like with event listeners, we can say we can create another observable, or we can create an observable type with this from event observable creator, and that will just take in the element, the DOM element, and the type of event. So we'll just do a click event here. So this here represents the observable, and what we can do is we can subscribe to that observable so we become aware of its existence. And okay, so in our next observer function, when we click a button we get an event, and in this particular case we're going to get a mouse event, so we can just give it that type as a parameter. And if you're not familiar with TypeScript, I've got a video series on that, so check that out. But then we can give back a console log for that event, and we'll just get the client X for that particular event. So I'll go ahead and save that. We just get this, this should be a lowercase c, and if I save that, and let's say, okay, so we still got this other observable running in the background. Let's just turn this off here, and we no longer need to subscribe directly to that, so I might just put that up here and save that. And now we have this click here button, so we click that and then we get the X direction where we clicked on that particular element. So they're probably, these four are probably the most basic and useful sort of ways to quickly create an observable. So what we'll do now is we'll take a look at the pipeable operators, and they're the second and more powerful type of operators that we can use to manipulate our data or do something with our data. So I'll just write here pipeable operators, and I might just go ahead and comment this out and comment this out too. So yeah, pipeable operators, they're functions that take an observable as its input and returns another observable. When they're called, they do not change the first existing observable instance. Instead, they return a new observable whose subscription logic is based on the first observable. So let's just go ahead and just see an example of that. So what we'll do is we'll just create a simple observable with of, and our first pipeable operator we'll take a look at is the map pipeable operator. And one thing I'd like to just highlight here is when we're importing pipeable operators, we import it from RxJS/operators with an S. So most of the creation operators are coming from RxJS, and most of the pipeable operators are coming from the operators section in RxJS. So what we'll do is we can just create a basic observable. So we can just call it OBS, a constant observable, and this time we'll just do 1, 2, 3. So we've transformed that into an observable now. And what we can do is we can subscribe to that observable. Might just copy this line here, and we can console log out whatever value we get there. So I might just change this to make it more descriptive, and I'll change this to val, and then I'll use a template literal in the ES6 notation and just console out log the particular value. And we've seen what this will do, so it'll be no surprise to see that this will output value 1, 2 and 3 all on separate lines. Okay, so what our pipeable operator map will do is it will so we have this observable 1, 2 and 3, and we wish to return, say, a different observable. Let's say we wanted to return numbers 2, 4 and 6. We return that new observable based on this initial observable. So with this data 1, 2 and 3, we essentially want to double it, but we don't return the original observable, we return the new observable to be subscribed to based off that initial observable's stream of data. So map will give us back a new observable, and then we can subscribe to this transformed observable. And the map operator is responsible for implementing the transformation logic. So let's just see that in action. So before we subscribe to the observable, we need to pipe it, hence the name pipeable operator, and we can do that by calling the pipe operator. And this pipe operator is used in conjunction with the pipeable operator. So we've seen the pipe operator before. We're piping the first observable, which is this 1, 2, 3 data. We're going to do something with it and transform it into a new observable, and then we're subscribing to that new observable. So let's go ahead and we'll use the map pipeable operator, and we can do that just by calling map like this. And so basically it works similar to map in JavaScript. So for each one of these values, 1, 2 and 3, so for each value, and I'll just call each value x, we can map this to 2 times x. So now if we subscribe to that, we can see that we immediately get back value 2, value 4, value 6. And this is where you can start to see the power of operators. We can essentially intercept asynchronous, or in this case synchronous, both synchronous and asynchronous code, and we can do something with that, or modify it in some way, or transform it, or filter it, or there's many different combinations of things we can do. And we can return, we can, you know, get those values back, or do something with those values that we get back based off the stream of data fed into it. So we can start to see how powerful this can become. And okay, so we'll just take a look at some other sort of observables, and I'll just comment this one out, and I might just copy it for now. And rather than this map core, one that we can use is we can say, okay, we can say first, for example, and there's a ton of these, and I might just import that as well. So import first, and this sort of is self-explanatory. We can just get back the first value. So for all the values we passed in, we might just want the first one, and this can be quite useful if we want to do some sort of you know, some sort of request based off only the first value we receive rather than each individual ones. So that's just another pipeable operator, and there's a whole list on the RxJS website. There's a whole bunch of creation operators, and they categorize the pipeable operators into things like transformation operators, which is what map is, and there's also filtering ones, and we'll take a look at filter in particular, and there's join operators and all different types. But I'm just going to cover the core, the main ones that you would use, and give you the information you need to be able to work out any of these types. So yeah, there's a lot of operators, but there's a lot of power you can get with those large range of operators. So anyway, I'll just comment that out since we've seen the first pipeable operator. So I guess the next one we'll take a look at is the filter operator. And okay, so let's just get that in from RxJS operators. And what we'll do is we'll create a interval observable. So we'll have a different type of observable here. It's still an observable, it's just created in a different way. So let's just say const observable equals let's see, interval, and we'll use the same as before. We'll just say interval of 1000, and that will be our observable that we created. Now what we want to do, and we do want to subscribe to this observable as well, so we'll copy that bit of code there, and in our actually I might combine that straight on there like that, and before I subscribed to it I want to call pipe, and I might just sort of open that up like that and put it on the next line here. I might just save it, actually they'll reformat with the prettier extension. And okay, so inside the pipe we have the pipeable operator filter, and what this is going to do for us is it's going to take the stream of values that we receive. So in this case we're getting 0, 1, 2, 3, 4, 5 forever, and let's say we only want to return every even number. So what we can do is we can filter these values, and we take in for each value we can return, say, val modulus 2 equals to 0. So what this val modulus equals to 0 will do is it will result in either true or false. So a filter requires a Boolean expression to be evaluated, and if it's true then it will pass the value into the subscribe method, but if it's false it will no longer reach the next method. And if there was another nested pipeable operator, it wouldn't reach that. So it does what it says it's going to do, it filters out values. And this line here in particular, that's just saying the remainder after division. So if the value is 0, okay, so that will equal 0, 0 divided by 2 is 0, that equals 0, so that'll be a result. 1 divided by 2, well, there'll be 1 left over in that case, so that won't equal to 0. 2 divided by 2 is 0, and essentially 0, 2, 4, 6, 8, 10 and so on will result in a true expression there. So that means those values should be logged to the console with our next observer. So let's go ahead and save that. And we take a look here. Okay, we get 0, 2, 4, 6 and so on. So that is the filter observable. Oh, sorry, the filter pipeable operator. So the next one we might want to take a look at is throttle time. So let's take a look at this. And for this one I'll make use of the button once again. So let's just get this in here like that. I'll comment this one out here. And our button we've named up here already. And I might get this from event as well. So let's uncomment these. And yes, we've got throttle time. We're going to need from event. So let's just get that here as well. Was it erroring? Okay, so that needs to be, that's a creation operator, so it does not need to be there. That can be here, like that. So we're selecting the button dominant element, and then with that button for a click event we're subscribing to it, and then we're logging out the client X value. So what we want to do is we want to do exactly that, but before giving out that client X value, let's just remind ourselves what that's doing. So we click this and we keep clicking it, and we're going to get the value for wherever our mouse is located on that button. But let's say we want to sort of, on the first click we want to get it back, but then we want to put a delay on it. So let's say we wanted to make it so that if you click this multiple times, only the first result will show, and then have, you know, at 1 second between, let's say, before we can output another value to the console. So we can sort of intercept our first observable with a pipeable operator, and we can get the information from the first observable. So that's just, you know, whenever we click on it, what the X location is. But we can pipe to, and what we can do is we can say throttle time, and we can just put 1000 here, so that's 1000 milliseconds. So now if I click it, we get it back to the first one, and I click it again. But if I keep clicking it, notice that only once every second it will display that, and that could be useful if you're, you know, paying for a server and you don't want to overload your have a huge amount of HTTP requests, and you're, you know, paying per request or something like that. So, you know, you might want to sort of limit that, and that's a perfect example of where that would come in handy. Okay, so that's that. I guess what we can take a look at now is an input field, let's say. So let's say we have an input field here like this, and we'll just say type text. We can just take a string. So what they'll do is they'll just, well, what it should do, yeah, so it should just create this input field here. And let's say we just wanted to log out our value into the console just to get things going. So what we can do is might just copy this sort of form here. So let's say let input, and I'll just change this to input, and I can change this type to input. So there's an input type, so just like there's a click type as input, so whenever you type in data into the text box or something like that, they'll trigger that event. So we're using that from event creation operator once again. And okay, so we won't use this pipe here just now, we'll just see what this is going to do for us. But it should be noted that rather than a mouse event this time, we're going to have a HTML input element. So what we can do is we can say that this event is going to be an input event, and what we're going to do is we're going to console log out the value. So we want the target value, and this is going to error because it's not going to know the type. So what we need to do is we need to sort of make this a HTML input element type, just like that, and we surround that. That'll be the target, and then we can take that target and we can get the value of that target. So we're just sort of coercing the type there. So now with that, when we type something in, we get the string back that we typed in. But just like in the example where we're limiting the HTTP requests to the server, we may only want it back every so often. And okay, so let's see how we could do that. And what we might do is we might, rather than throttle time, and I might just copy this down here, get it closer to where our code is. So we'll put the imports here. And rather than throttle time, we might use debounce time. And I'll show you the difference. So since we're going to use a pipeable operator, we want to transform the first observable into something. So we can just say pipe, and we're going to do something, and then subscribe to that. And then what we'll use is we'll use the debounce time. So, okay, so we got debounce time, 1000. And if we type in something here, notice that you have to wait 1 second to after you finish typing for that to be displayed. So that's the key difference. So rather than it being recognized on the first keystroke, it's recognized only after 1000 milliseconds after that last input event. So that's the key difference between throttle time and debounce time, where throttle time, it takes the first value and then sort of will delay the it won't work until the specified period of time is reached. But debounce time doesn't work initially, and then it also is a 1 second after it finishes rather than a delayed period. But often in RxJS we don't just use one pipeable operator, and this is sort of why we use this pipe sort of methods, because we can actually chain a bunch of pipeable operators together. And one really common one to use is distinct. So actually I might distinct until changed. And okay, this is automatically imported for us. So what this will do is it will, in theory, what it should do is, let's say you type in a name. So I type in, say, John. And then if I type in, say, Johnny, but then I go back to John before that period of time, what it should do is it should recognize that the string hasn't changed. But notice that it has actually shown us John log twice. So you might be thinking, well, is this broken? And what's going on here is the method is sort of true, but what we're inputting into that is a event. So the value of emission is the whole event object, not just the value. So something else in the entire event object is likely to have been changed, and it will have been changed, hence that it's not distinct. So one method we can use to alleviate this is we can, okay, so we've seen the map method, so let's go ahead and chain that before we get to the debounce time or distinct until change. So what we can do is we can say, okay, we can take the map and okay, so we know that the map is going to be some sort of event, and we know it's going to be an input event. So let's give it that type there. And what we're going to do with an input event is we're going to get this thing here. So we can go ahead and have this arrow here to that. Let's see here. Is there an extra arrow now? Okay. So that. Yeah. Oh no, we need that. That's the pipe exit. This just needs a. This is like that. oh no, I need this one here. So that's the blue bracket, and then we probably need this purple bracket to close the map as well. Okay, so, and then we need a comma here. And now notice that what we've done here is we've taken the event sort of input, and for that event input we're going to give back a I might change that to E. We're going to get back just the value of that. So rather than subscribing to the event, we can subscribe to the value itself, and we can just go ahead and just say value here and console log that value just like that. And I think we need a another one of these. Okay, so let's take a look at this. So now if I type in John, I get back John. If I type in NY and backwards space it before this 1000 milliseconds, notice that it only logged it out once here. So we've helped a theoretical sort of server load. We've debounced the time, so it takes the input event, but it sort of filters through them, let's say, and it just gives us back the value itself. So with the value itself, if that value is the same after a 1000 millisecond debounce time, then it's distinct, so it won't it'll sort of be filtered out through the subscribe, and it won't be passed into the subscription. So yeah, so rather than using this map in particular, we can see that, you know, what I might do is I might just comment out this pipe here entirely, and we can just take a look at what the event object's giving. So let's say I type in something, so I just type in J, we get this input event, and it's just an object of objects basically. So we have an object, and then let's say in target, for example, we have, it's a another sort of key value pair nested within. So what we can do to sort of get information values out of objects, so we sort of want to pluck out the value from the object, and if we're nested, we want to sort of pluck out, say, target from the input event object, but then we also want to sort of pluck out the value as well. So what we can do for that particular case is we can actually use, rather than this sort of convoluted mapping each time and getting through the input and all that sort of stuff, what we could do is we could get a pluck pipeable operator from the RxJS operators. So rather than this whole map thing, what we can do is we can just say pluck, and recall that we wanted the input target value. So we are getting the input value from the input event, and then we sort of want the target, that'll go into that target sort of object, and then we'll go into that, and then we'll go to value, and then we'll pluck out that J there. So we can just pluck out that value like that. We can save that, and now we can say type in John, we get John a second later. If I type in NY and back again, the user changed the data, but it was before the 1 second delay time, so it's still distinct, thus it only made the one request. But then if I did actually change to Johnny, held that for a second, then you get that back. So this was like a broad overview of the power of RxJS operators. We talked about the creation operators, in particular of, from, interval, and from event, and then we talked about various pipeable operators such as map, filter, and you know, pluck, and all these: first, historical time, debounce time, distinct until change. And if you need to look further into any particular operators, you can just check out this rxjs-dev.firebaseapp.com/guide/operators website. This has all of the other different categories of operators. So, you know, for example, there's a merge and merging operators together, and merging observables together, and there's utility operators and stuff like that. But I hope with this video tutorial that you're able to understand observables, you understand operators, and you should be able to at this stage sort of use them as needed. So in the next video I'll probably discuss subjects, and then I might get into some other sort of scheduling in the video after that. So I hope that helped, and please subscribe to my YouTube channel. Thanks so much for watching.